AI is poised to completely change medicine and medical training along with it. But what if the very tool we're building to help expert doctors actually stops a student from ever becoming one? It's a huge question, and we're going to dive into a framework that tries to solve it. So think about this paradox for a second. We've got these incredible AI tools that can act like a co-pilot for a seasoned doctor, right? But if you hand that same exact tool to a first-year med student, it might do more than just not help. It could actually damage their ability to learn. And that's the core problem we're going to get into. Now, to be super clear, this is not an argument against AI in medicine. Not at all. The problem isn't the tech. The problem is a failure of timing. So the real question isn't if we should use AI, it's when and how we should introduce it to someone learning to be a doctor. And to really get why timing is everything, you've got to understand something called cognitive load theory. So just picture your brain's working memory like a small desk. You can only have a few items on it at once. If you just pile on too much stuff, not only do you not get anything done, but nothing gets put away into your long-term memory. Real learning is all about managing what's on that desk. Okay, so this is where it all clicks. An expert doctor has this massive mental library of past cases and knowledge, these things called schemas. For them, an AI is like a helpful assistant that handles all the busy work, freeing them up to focus on the really hard problems. But a novice, their library is practically empty. They need to struggle with that busy work because that struggle is what actually builds the library. If you give them an AI too soon, you're basically robbing them of the one thing they need to learn. And this quote just, man, it says it all. There's actually a name for this, the expertise reversal effect. It means the very same tool that can make an expert even better can absolutely cripple a beginner and maybe stop them from ever gaining that expertise in the first place. It's a really powerful and honestly kind of scary idea. So if that's the problem, what on earth is the solution? Well, the answer isn't to just ban AI. It's about being really smart and strategic about it. And that brings us to this idea of phased integration framework. So the whole thing is broken down into 3 phases, and each one is specifically designed for a different stage of a doctor's training. It kicks off with something called the cognitive firewall, then moves into the sandwich model, and ends with the student becoming an orchestrator. Let's look at what these actually are. All right, phase 1, the cognitive firewall. This is for those early preclinical years. And the goal is dead simple: build the foundation. During this phase, generative AI is basically off limits for core learning. If you're in anatomy or pathology, you have to do the hard work yourself. You have to grapple with the material and build those mental maps from scratch. You got to learn to read a map before you get a GPS. Okay, next up is phase 2 for when they're in their clinical years. And this is where it gets really smart. It's called the sandwich model. Here's how it works. First, the student does all the work themselves. They talk to the patient, they come up with a diagnosis. That's human first. Then, and only then, they ask the AI for its opinion. That's AI second. But here's the most important part: synthesis. The student has to compare the 2 outputs, analyze the differences, and justify their original thinking. They're not just getting an answer, they're being forced to have a debate with a very smart colleague. And that all leads to phase 3, which is for residents and practicing doctors. So once you've built the foundation and you've sharpened your critical thinking with that sandwich model, you get to graduate to being an orchestrator. At this point, the goal is to use AI to manage incredibly complex systems at a huge scale, using it as a powerful collaborator, not as a crutch. And this is where things get kind of wild. They have these simulations, right? A resident might have to manage a disease outbreak that affects 500 virtual patients in one afternoon. 500! Now, their job isn't to treat every single patient. It's to supervise the AI agents that are doing the treating. They're being tested on something new called algorithmic vigilance. Can they spot that one single case where the AI is making a subtle mistake or showing some kind of bias? It is a completely new skill for a new era of medicine. Okay, so a system like this is great, but you can't just hope that med schools decide to use it. If this is going to work, it has to be backed up with new rules, new regulations, and new kinds of certifications. You need real structural guardrails. So, there are 2 big policy ideas on the table. First is a human-in-the-loop certification. You can think of it like a manual override test. Before a doctor gets certified to use an AI to help read, say, an ECG, they first have to prove they can read one perfectly without the AI. Makes sense, right? Second, the audit trail. This means we stop grading students on just their final answer. We start grading their process. We want to see your prompts, show us how you question the AI, prove that you verified its sources. So why does all this matter so much? Well, it's all designed to prevent something called the buzzing effect. This is a very real, documented thing. It's the de-skilling that happens when we get too used to our automated tools. We absolutely need doctors who can step in and take over when the technology fails, not doctors who are completely lost without it. So after all of this whole new way of training, what kind of doctor does it actually create? What does the future physician even look like? This quote, for me, just sums up the whole philosophy, and it's so brilliant because it's just common sense. I mean, think about it. We don't ban calculators from schools, but we make damn sure kids learn how to do math first. We don't ban GPS, but we want people to have a basic sense of direction. It's the exact same logic, just applied to this incredibly powerful new technology. And this, right here, is the ultimate takeaway. In a world where an AI can know every medical fact ever published, the doctor's job has to change. They are no longer a walking encyclopedia of facts. Their new job is to be a sense maker. They are the human expert in the room who has the wisdom to know when the data doesn't quite fit the patient, when the algorithm is subtly wrong, and when technology needs to be guided by human experience. And that, really, is a future worth building.